Vanakkam. Welcome to this course on biomedical instrumentation. We have been looking at EMG and we looked at some of the factors that affect EMG recording and EMG quality. In this video, we will focus our attention on nerve conduction velocity and nerve conduction velocity studies. NCV means nerve conduction velocity, NCS means nerve conduction study, and how we can use surface EMG to measure median frequency, which is an indicator of fatigue. Essentially, nerve conduction velocity is a diagnostic measure in EMG that evaluates how fast electrical signals travel along a nerve. Essentially, there are these diseases that in which the velocity of conduction is compromised. Those are neuropathy or nerve damage and myopathy or muscle damage. Do check. Also, there are others like myelination disorders, MS, GBS. What is MS? Multiple sclerosis. GBS is Guillain-Barré syndrome. One is a demyelination disorder of the central nervous system, the other is a demyelination disorder of the peripheral nervous system. Do check the difference between the two. In my other course on neuroscience of human movement, I have dedicated one video each for each of these topics. It is a long, huge topic of neurophysiology and pathophysiology beyond the scope of this course. So, essentially you are interested in assessing how well the peripheral nerves function and how properly they function, detecting nerve damage, compression or demyelination. That is what I was discussing. So, essentially nerve conduction velocity is the distance travelled by the proximal latency by the minus the distal latency. So, total latency. Latency is the time delay between you are giving a stimulus and that you are measuring between 2 points, and you know the distance that needs to be travelled, the length between the two stimulation points in mm or in meters, and the latency, the time delay, and the unit of nerve conduction velocity is in meters per second. What is the maximum velocity at which neurons can conduct? It is about 120 meters per second. Typical motor neuronal nerve conduction velocities are between 50 and 70 meters per second, depending on the condition. I am giving some typical values, some exemplary values. Okay. So, this essentially quantifies and gives us an idea about the conduction speed of the neuron nerves, and essentially detects these problems which are compression or damage of the nerve, or if it is a compression problem, then it essentially is a carpal tunnel syndrome. For example, is a compression neuropathy of the median nerve. We have worked on this topic, and we have also recently published on this topic, comparing how force varies versus force synergies, coordination varies. It turns out that coordination does not vary as much as the force. This is the paper by my student Thomas Jacob and my colleagues in various clinical settings. Jacob et al. Scientific reports. Okay. You just Google Jacob et al. Scientific reports carpal tunnel syndrome. This will be the most recent publications, or you can check my website. In that website, I have given the title of the paper and the entire paper for you to read. And this is a topic in which we have worked on carpal tunnel syndrome, but that now we have digressed. The point is that we are interested in nerve conduction velocity. This might give an idea about nerve damage or nerve compression or demyelination, such as demyelination disorders such as multiple sclerosis and Guillain-Barré syndrome. Okay. So, if you use surface EMG using surface electrodes on the skin, it essentially measures the speed and the strength of the electrical signals that goes between 2 points. Since you know the distance between these 2 points and you are measuring with a relatively high sampling rate, you know the time delay that happens between, and since you also know when you are stimulating, between the stimulus and the first delay and the second delay, you know the time. What are the benefits? Essentially detects nerve damage or nerve destruction. Often it is done along with EMG or full neuromuscular assessment. It helps identify presence, location and severity of the neuronal disorders or muscle disorders. Sometimes this sounds may be, this nerve activity may be used with along with audio amplifiers and speakers. This process already I called as sometimes this is also called as a sonification. Right. The other is the median frequency. This is the frequency that divides the power spectral density into exactly two halves. Median means median, the statistical median, into two halves. This essentially represents the frequency content of the EMG signal. Why is median frequency so important? Because median frequency is a biomarker, is a critical biomarker for muscle fatigue. As fatigue increases, median frequency shifts to lower frequencies. Median frequency shifts to lower frequencies. This indicates that motor unit firing rate and fiber conduction reduces. Now, this rate coding and size principle are beyond the scope of this course. Physiology, neurophysiology topics. Please do check my other course on neuroscience of human movement. I am referring this to you so many times. I hope some of you will be inspired to take the other course. The typical range in non-fatigue muscles between 100 and 150 hertz. In fatigue muscles, this median frequency progressively reduces. As fatigue increases, the median frequency keeps on reducing. This is the median frequency analysis of or simply using surface EMG, I can detect fatigue of a muscle. With this, we come to the end of this video. In this video, we looked at nerve conduction velocity and nerve conduction studies and how we can use median frequency using surface EMG to assess muscle fatigue. With this, we come to the end of this video. Thank you very much for your attention.